wanted to show you how you could use kerf bending to make a wooden chair in Fusion 360 using the sheet metal tools. For example, here, if I select this face, you can see that it is actually able to unfold it and do a pretty good job at simulating how the material will bend. And we're also going to go over how, if you go to the flat pattern, how you can use kerf bending patterns. For example, if I just put a hole here, that didn't work at all. Maybe it's on a flat face. Interesting. Where's the other hole? Is there an update button? I think you might actually have to do it flat. Oh, you're going to be machining it flat anyway, so ignore the hole, both holes. Yeah. So the way sheet metal tools work, I'm going to go to the end of the timeline here. Just notice there's no seat now. The two sides are actually the same part, just to make things easier. I realize now they actually would need to be mirrored because of this this mortise and tenon detail, but we'll ignore that for now. The first thing I did is I made a new component, and I'm going to call this bent seat 2, because I made one earlier called bend seat, but we can ignore that and actually remove it completely. And the thing you actually want to define with bent seat is just a single line that you're going to base your bends on. So I am going to make a new sketch on this plane. And then you just use an align tool with sharp corners. You just define like the approximate, what you approximately want your piece to look like. Notice this has sharp corners, and that's not going to be possible with bending plywood, but you'll see why we're doing it sharp in a second. Then you click Finish Sketch, and again, you just have a single open line, and you go into the Sheet Metal tab, and you create flange. And then with chaining selected, you just click the line that you have in mind, and you're going to extrude that out. And you might notice that the corners are pretty sharp right now, but that will change in a minute. And I'm going to extrude out to the width of the chair, which I have as a parameter as width. And you're like, wait a minute, this isn't plywood. You know, this is thinner than plywood. It's bendier than plywood. This is actually sheet metal. But if we go into modify sheet metal rules, you can see on my screen that the sheet metal on the left is sharper than the sheet metal on the right. But if we go into here, we can go steel on your screen, and you can do edit rule, and we're going to make a new custom plywood. And for thickness, it's 1/2 inch. So I'm just going to type, since the units, for some reason, it's asking me to do this in metric, 0.5 inch. So now I change that. You can see right away the thickness of the material has doubled, has gotten a lot thicker. The K factor probably shouldn't change that much. That refers to how much the material stretches. I don't know how much kerf bent plywood stretches, so I'm just going to leave it as the steel because it's pretty approximate anyway. But under bend conditions, we're going to have to change the bend radius. So again, we mouse over and we click the little pencil. And under bend conditions, we can change the bend radius, which is currently just the thickness of the material, to, let's say, the thickness times 10. So 1/2 inch times 10 would be a 5 inch radius, so a 10 inch circle. So that's almost like a basketball. in terms of how round it is. It's more like a bowling ball. And now I'm going to click OK. And now you can see that these curves are really soft. I'm going to close the sheet metal rules. And there are two ways to unfold things in Fusion. One is the modify unfold, and it's going to ask you for the stationary face. This is kind of more intuitive. Let's try this. This maybe this is the one I wanted, because before I was getting a little mixed up. Yes, okay, sorry. So don't use flat pattern, use unfold and refold. So while it's unfolded, and you can refold it from the sheet metal tab, refold, and then modify, unfold. While it's folded, you can see what these lines kind of represent. You know, it's a line and then a line for the beginning and the end of a bend, and then a line and a line for a beginning and the end of the straight part. A line and a line to span the bend, a line and a line for the straight part, and so on. The top part is all straight. So if I want to use kerf bending on this, I'm going to make some more parameters. I'm going to do kerf diameter 0.5 for the diameter of the bit or the diameter of the slot we're going to use. Kerf gap, which is the like the distance between the hot dogs, like end to end. I'm going to make that 1 inch. Kerf width, I'm going to make that 3 inches seems right to me based on what I've seen online, but we can change it later. And kerf slot to slot, I'm going to make that 1/2 inch also. I'm going to try something else. I'm going to try, you can also do no unit parameters, things like kerf quantity width, like how many slots wide are we going to need? And I think logically we would need 18 inches, which is the width right now, divided by 3 inches plus 1 inch. Because 18 inches is the width, 3 inches is the width, is the length of each kerf, and 1 is the gap between the kerfs. So that's 4.5 inches. We probably also want to have one extra to make sure that that it goes over. Plus 1. Or maybe even just plus 2. So if we copy this to here, we get 6.5. But I don't want 18 to be 18. I want it to be width. And I don't want 3 to be 3. I want it to be width. Oh, that's complicated. You have to divide every unit that has units. So at the end, we can just divide it by 2 inches. That's kind of weird, but you have to divide it by 1 inch because the other things have units. And you need to get rid of that unit since this is a no unit, since this is a quantity, like how many things we're going to be using. This is going to be yucky. width divided by kerf width plus kerf gap. What's going on? Okay, 1, that's got the parentheses. Anyway, let's just make it 5. That was too much. Great, now I'm gonna unfold this using this. And now that it's unfolded, I can make the other things invisible. And I wanna add some kerf. You know, I'm just gonna do it for the whole rest of the thing. So the whole thing is gonna, because it'll be cleaner. I'm gonna create a sketch right here. And I'm going to make a slot. Kerf diameter. And I use the dimension tools from here to here. Kerf width. I'm going to add a point. I'm going to add these 2 points, and I'm going to drag that so now it's coincident. I'm going to do that again. I'm just going to draw it this time. Last time I know I copied it, but I'm going to just draw it this time. I think it might be easier. Width, kerf width, kerf diameter. I'm going to use the dimension tool between here and here for slot to slot. I need to use the dimension tool from make a point here from here to here. And this is going to be kerf gap divided by 2. Divided by 2 because it's between this one and its imaginary friend over there. Now I can do create rectangular. Well, I have 2 choices. I can do the rectangular pattern now, or I can do it after the cutting. I'm going to do it after the cutting. So I'm going to click finish sketch. I'm going to click extrude. I'm going to extrude both of these negative thickness. And now I'm going to go into create pattern, rectangular pattern. I'm going to do the features, and to pattern a feature, you actually select it down here in the timeline. You could also do the faces, but it would be more steps. And for directions, you can pick lines on the part. In this direction, my quantity, I'm going to do kerf quantity width. And in the other direction, I'm going to do 10 for now. The spacing is going to be kerf width plus gap, kerf gap. In this direction, the spacing is going to be kerf diameter plus slot to slot plus kerf diameter plus slot to slot. I could have done it also with 2 times. Compute option, instead of doing adjust, I'm going to do identical or optimized because it just asked me to in a pop-up window. I have no idea what that means. I'm going to do 11 or even 12 instances for the, and now I'm going to cross my fingers and I'm going to click OK. Cool, well, something went weird. I'm gonna go back into this feature. I'm gonna try identical. There we go. Something about optimize made a mistake. So now if I go back into modify and parameters, since my kerf width, quantity width, and I didn't even use it because I got overwhelmed. Kerf quantity height, not used. I was gonna make it 99. Since these aren't parametric, gotta delete it and make a new one because I got the unit wrong. Whatever, we're not gonna bother. Since this isn't parametric, there's gonna be an issue, which is if I make my kerf diameter 0.25 inches, suddenly there aren't enough kerfs anymore. Or if I make my kerf width 2 inches, they're not gonna reach the other side anymore. But for now, I can say this is good, save it. I'm gonna refold the faces. I'm glad I saved it. And now we did some kerf bending in Fusion 360. And for machining it, you should just be able to machine it from the flat pattern. Yeah, I don't know. I think depending on the material, this might not be strong enough. I think that you might need to use a smaller bit and larger gaps. But yeah, who knows? This could definitely work.